students, let us study about integers. Before going to integers, let us recall natural numbers. You know what natural numbers are. All the counting numbers, these are the counting numbers. When you start counting, we start counting from 1 or not, like this. 1, 2, 3, 4, 5. So there is no greatest natural number. And you see, when we have started from 1, so 1 is the smallest natural number. Remember it. Next, we will move to whole numbers. Let us recall, and after that we will move to integers. Whole numbers. And you see, there is no 0 here in the natural numbers. No. So the smallest natural number is 1. But in case of whole numbers, you see, all the natural numbers along with 0, we have to take 0. Like this. So you see, in case in the whole numbers you see, there are natural numbers. But there is no 0 in the natural numbers. Okay? So, we can tell all the natural numbers are whole numbers, but all the whole numbers are not natural numbers, because 0 is a whole number which is not a natural number. Okay? So, let us move to integers. What are integers? These are also numbers. So, why do we need it? Why did we need these numbers? Integers. What are integers? We will know why these numbers we needed. But first, you see, first we should know what are integers. You see, the whole numbers with their negative numbers. Are combinedly known as integers. So the whole numbers, so 0, 1, 2, 3, like this, and also +1, +2, +3, we may write like this, and also -1, -2, -3, -4, like this. So these are the negative numbers. You see, they are negative numbers. We were using 1, 2, 3 like +1, that is +2, that is +3, but we are using now -1, -2, -3, -4. What does it mean? Why it is needed? Suppose you see, I am writing an equation. X is the unknown number and x plus 5 is equal to 2. That implies, what is the value of x? You transpose +5 to the right hand side of the equation. That is 2 minus 5. We take away 5 out of 2. That means that is the, we will know it later. Just I write this. That is equal to -3. So what does it mean? Why these are useful? -1, -2, -3, -4. What does it mean? Just we will know that. Just I want to erase it. Suppose you have gone to a shop for marketing. You want an article you want to buy. You have gone. Suppose you want to buy a pen and you have taken 10 rupees with you. So you asked the shopkeeper, what is the cost of the pen? And the shopkeeper told the cost is 13 rupees. But you have taken 10 rupees. But the shopkeeper belongs to your locality. The shopkeeper knows you very well. So he gave you. But you will have to pay 3 rupees. In this case, what does it mean? You see, you are left with, give a minus sign. You give a minus sign. So this minus sign or this negative sign helps us to know the situation. It reads the situation, helps us to read the situation. What? Now I will have to pay, you will have to pay. You will have to pay 3 rupees. So this sign helped us to read the situation. So we may write integers are useful to denote ideas, IDE, ideas that are opposite in the direction of sense. It helps us in the direction of the sense, how you see. Suppose this is the level of water. Suppose in the sea, it is the level of water in the sea. Suppose a flight is here at the point A, and from the sea level this height is, let it be, suppose 500 feet. Okay, you know feet. So this height is 500 feet. Okay, so this is the sea level, water level of the sea, and just below this point A, below the water level, just this height is, suppose 200 feet. There is a fish. Suppose it is at here. So integers are useful to denote ideas that are opposite in the direction of sense. That means, you see, this is the sea level. So this is up, and below the sea level, that is down. So this is up, and from this level this is down. So for the up, in the direction of upside, upward, it is positive, and below or down, we may write negative. So it is plus 500 feet, and we may write minus 200 feet. So this minus this reads the situation. What is the meaning of this negative sign? This indicates, and you see here is the positive sign towards the towards the upward side. It is above the sea level. So it is in the upward direction. So we gave the positive sign. And from the sea level, when you went down, we gave negative sign. So these signs read the situation, helps us to read the situation. So in the direction of sense, we use integers. In the direction of the sense, which are opposite to the direction of sense, these are helpful and this is useful in our daily life. So this is the introduction video on integers. Just I want to tell you, I want to make you understand why are we using integers? What is the need? -2, -3, -4, what does it mean? So how these signs helps to denote ideas that are opposite in the direction of sense. So you see, suppose there is a positive sign, the negative sign. So you may write negative because you see negative NEGATIVE. In short, you may just give like this last two letters. So like this positive, you see positive. Last two letters or before that you may write also like this in short form. Okay. So positive sign and negative sign. You see. In which cases, if we take upward, downward, up, down, or above, below. Suppose if you take right towards right, if it is positive sign, then left is negative sign. If you take left as positive sign, then you will have to write right as the negative sign. But generally we write right as we take right as the positive sign. So we write negative. We will give the negative sign to the left. Increase, decrease, profit. You could take profit as the positive. So plus. Deposit. We deposit money or not? If you deposit, if you take deposit as the positive side, so for withdrawal, these are the negative side. Just to note it. And you see, we have to represent the integers on the number line. So, before going to integers, let us start from the natural numbers. You see, use the ruler, and with the help of the ruler, you just represent a line first. Okay, so strictly it is an arrow, but in mathematics electrical, so this is a number line, and you see, you mark and label it 1, and towards the right of 1, you mark as 2. So this is called the unit distance. This is called the unit distance. So you create such unit distances towards the right like this. The same distance from this point to this point, this distance is the unit distance, and you create some more unit distances like this 3, 4, 5, 6, 7, on and on like this. So you see this distance, okay, so the length of this distance is equal to the length of this distance. So these are called the unit distances. From this point to this point, from this point to this point, the measurement is set. These are called the unit distances. So we have to proceed accordingly. And you see, when we are showing the natural numbers, we have already represented the line and we have placed the numbers, natural numbers. There is no zero. So we have started from 1. You will have to mark. So 1, 2, 3, 4, 5, 6, 7. So these are the unit distance. And we can write like this. And these are for natural numbers. Natural numbers. Okay. I will draw for whole numbers. You see, you mark and label at 0, and to the right of 0, give a second point, do 1, then maintain these unit distances towards the right. The next, mark it as label as 2, like this. And in this case, you see, we have started from 0, but not here, because there is no 0 in the natural numbers. Because when you start counting the objects, or when you start counting from 1. But you see, in case of whole numbers, we have started from 0. So this is the number line we could show. And we will come to integers. So this is the representation of a line, and mark a point and label as 0, and towards right 1, you write 1. So this is 1 unit distance, and you see towards the right of 1, maintaining the same unit distance, you write 2, write 3, write 4, like that, like this. So this is we are going towards the right of 0. This is in the positive direction. This direction is in the positive direction. So like that, maintaining the same unit distance, we will move towards the left of 0. So we may call it -1, -2, -3, -4, -5. And already you know, in case of the natural number, the smallest natural number is 1, and there is no greatest natural number. In case of whole numbers, you see, the smallest whole number is 0 or what? And there is no greatest whole number. And in case of integers, you see, how written 0, it is neither positive nor negative. It is a special number. It is neither positive nor negative. And these are the positive integers. These are the positive integers. And these are the negative integers. So we may write like this: 0, ±1, ±2, ±3, like this. So every natural number is a whole number, but every whole number is not a natural number. So all the whole numbers are integers, but all the integers are not whole numbers. Why? Now you see, the negative integers, they are not included in the whole numbers. So all the whole numbers are integers, but all the integers are not whole numbers. So you just understand. We will erase it. We will learn how to add to integers. So rules for addition of two integers. So this is most important. So you will have to be fundamentally clear. How will we add two integers? What is the rule behind it? This is most important. Students, please follow it. So first point you see, when two integers of opposite signs are added, what will you do? Now first you take the numerical difference. Take the numerical difference. And next, what will you do? Now give the sign to the difference. What we got? But what sign we will have to give here? Now the sign with the higher numerical value. So we will take an example and you will be here. You see, and give the sign of the higher numerical value. To the difference. So let us take an example and we will see it. Suppose 2 plus of minus 5. So rules for addition, you see, this is the sign for addition, and we will have to add 2 is an integer, it is a positive integer. Here it is plus sign, but it is not net in initial. When it is equal, so I erase it. It is a positive integer, and here it is minus 5. That means it is a negative integer. So it is a positive integer, it is a negative integer. Just we are adding. So rule for addition of two integers, and we have taken when two integers of opposite signs are added, what will you do? Now take their numerical difference. You see, minus 5. You omit. You ignore these signs. Just the numerical value is 5. Here the numerical value is 2. So which is greater? 5 is greater than 2. So you take the difference 5 minus 2. You know that is 3. You write 3 here. So first point is over. Because we took their numerical difference and give the sign of the higher numerical value. You see, 5 and 2. Out of 2 and 5, which number has the higher numerical value? 5. But the negative sign is the 5. So give the sign of the higher numerical value. Sign is minus. To the difference. Difference is 3. So you will have to give minus. So this is most important. So if I write like this, minus 5 plus 3, what do you do here? You see, it is a negative integer, it is a positive integer, and just we are adding. So what is the rule? So we have to follow the rule. So we have to take their numerical difference. So here is the numerical value is 5, here it is 3. So 5 minus 3, that is 2. And the higher numerical value 5 is with negative sign. So we will have to give the negative sign here. So minus 5 plus 3 is equal to minus 2. So just you remember it. So point 2, when integers of same sign are added, what will you do? Now we have to take the sum of two numerical values. Sum of two numerical values, and the common sign give the common sign to the sum. So you see, minus 2 plus of minus 5. So what we are doing here, you see, rules for addition of two integers. Here minus 5 is an integer, minus 2 is an integer, and we are adding it. You see, this is a sign for addition. We are just adding it. So what do you do here? Now we have to take the sum of two numerical values. Here you ignore these signs. The numerical value is 5, here the numerical value is 2. Ignore the sign. Do not consider the sign here. The numerical, only consider the numerical values. Here it is 5, here it is 2. So 5 plus 2, because we will have to take the sum. So 5 plus 2 or 2 plus 5, that is equal to 7. You write for 7. And keep the common sign. And you see, these are the addends. Minus 2 is the addend, minus 5 is the addend, and you see, here it is minus sign, here it is minus sign. So these signs are common, and that common sign we will have to give here. So give the common sign to the sum. So we got it or not? So these two rules are most important for you in the higher classes also, for the integers. You will have to follow these rules. In every step, in case of integers, you will face it in the higher classes also. So remember it. So now we will represent representation of addition of integers on the number line. And we have to represent a line, and we have to place the numbers, that is a number line, and we will add the integers, and we have to show it. So at least use a ruler. Mark a point, label it 0, and you create unit distances towards the right. You mark a second point, write 1, 2, 3, 4. These are the unit distances. The measurement of each distance is equal. All these unit distances are the equal length. You will just proceed like this. So from 0 to 1, so from maintain the same unit distance towards the left of 0. This is minus 1, this is minus 2, this is minus 3, this is minus 4, and so on. So already I have told you from 0 towards this is the positive direction and towards this is the negative direction. Yes, sir. So representation of addition of integers on the number line. So we take the example. Suppose we have to solve 3 plus 2. We know 3 plus 2 is equal to 5. But we have to represent it on the number line, and on the number line we will see that yes, it's right, 3 plus 2 is equal to 5. We could see. So how we do this? So first 3. Here it is a positive integer, and from 0 you move. Where is 3? Now here it is 3. Already here it is 3. So from 3 plus 2. So we have to move towards the positive direction. Yes or no? You see. So this is 3 plus 2 is equal to 5. Or you may write here. If not here, you can write here. In the NCERT books, it is also shown like this, and in other books like this it has been. From 0 to 3, then 2 units you will have to take towards the right, like this. But already you know it, you can see it that this is 0 and this is the 3, and then I will have to add 2 to 3. So we may not give the arrow here, because already we can see here from 3 we can start. We can see 3 and we can start towards right, we can add 2. Like this. Suppose minus 1, minus 2. No, we will not go to that. Suppose 2 minus 3. We will have to solve. We will have to show on the same number line. Suppose we are doing, that is 2 minus 3. What does it mean? We will have to take 3 out of 2. What does it mean? You see, that is equal to 2 plus of minus 3. 2 plus of minus 3. You can write like this. Because you see, just I am discussing a little bit about this, then we will move to number line. You see, 2 minus 3. That is equal to, first you write 2, that is the first number, and you see, here it is minus 3. Suppose 3 is an integer or not, and before 3 there is the negative sign. So here it is the integer is 3. So with 2, we will have to add the additive inverse of 3. So if you add the additive inverse of 3, so suppose for 3, the additive inverse, I will tell you later, just for the instance, just I am telling you. Additive inverse is equal to minus 3. So how will you get the additive inverse? Don't worry. Multiply the number with minus 1. The product will give you the additive inverse. Minus 3. Suppose the additive inverse of minus 6. It has been asked. Don't worry. Minus 6 into minus 1. Minus into minus, that is called plus, and 6 into 1, that is 6. So the additive inverse of minus 6 is 6. We will know when we will go through the properties of the integers. I will explain you more regarding this, just to mark it. And if you see when we are taking 3 out of 2, 2 minus 3, that means 2 plus of minus 3, we can write in this way. So just to reflect it, how you see. Here it is 2. Where it is 2 on the number line, you see this is the point 0, then 1, then it is 2, here it is 2. 2 plus, yes, I will move towards right or left. Now I am just looking at here, this is minus 3. So I will have to move towards left, not towards right, because it is a negative integer. I am adding, I am ready. Here, either I will move towards right or move towards, I am adding a negative integer. I will have to move. How much? You see, how many units? 3 units I will have to go towards the negative direction. So this minus 3, this sign, what does it indicate? Now move towards left. This creates a sense in case of opposite direction of sense, that are opposite to the direction of sense. Just it denotes the ideas. Just it helps us to read the situation, how the integers are helpful. These signs, minus 3, what does it mean? Because when we are counting, there are 3 objects, there are 5 objects, like this. But what is minus 3? So this sign indicates you have to move towards left. So already we have discussed, but briefly you see, towards right, if you take the positive direction, towards left, that will be negative direction. So right is positive direction, left is negative direction. When we have discussed on the integers up, down, upward, downward, above, below, profit, loss, just we are discussing. You see how the signs are helpful, how the integers are useful in our daily life. So you see, first 2 is here, so 2 is here. We have to move 3 units left. It shows in the left direction, and it is the numerical value is 3 here. You see, I have to move 3 units towards left. So you see, what is the value here? Remember, follow the rules for addition. When the integers of opposite signs are added, what we do? We take the numerical, we take the difference of the numerical values. So numerical values is 1, and the sign with the higher numerical value is given to the difference. And you see, already we have reached minus 1 here or not? And when we have calculated, you see, and the calculation is here on the number line. So you have to calculate like this. Suppose we will have to calculate, we will have to represent the additions like this. Minus 2, minus 3. So just to simplify, minus 2 plus of minus 3. That means 2 negative integers are added, and we have to show this addition on the number line. And these are integers, both are negative integers, you follow it. So These are the unit distances. Oh, this one became bigger. Excuse me. -3, -4, minus. These are the unit distances. Because I am not doing according to scale. Just I want to make you know. Just these are the unit distances, and each distance is of equal length. Okay. So -2 plus of -3. So first, where is -2? Now I have to move towards the left from 0. Here it is -2. Already it is here. I have to add. If a positive number I will add, I will move towards right. If negative number towards left, you see -3 is the negative number. So 3 units I will have to move towards negative. This sign indicates to go towards the negative direction. So you see -3 is here. Sorry, -2 is here. I will have to move 3 units. 1 unit, 2 units, then 3 units. So -5, and you calculate. What is the rule you follow? Both the integers are of same sign. So the common sign will be given to the sum. You take the sum of the two numerical values, 2 plus 3, that is 5. And give the minus, and this is the common sign. The sign of the addends will be given to the sign of the sum. If two integers of same signs, either 2 plus 3 is equal to 5. Well, we do it, that is it. And you see, this is the positive sign, this is the positive sign. We do not write. Yes or no? And you see, this is also positive sign. Like this, you will do it. So this is the representation. So you may write, we knew it, I just erase it. -2, -3. We could show like this. Okay? So this is the representation of addition of integers on the number line. Okay? So in the next video, we'll study about the representation of multiplication, division of integers, and also we will discuss about the properties which are most important, properties of integers. And basic operations that is addition, subtraction, multiplication and division. These are called the basic operations. You see, numbers are there. What do we do with the numbers? We add, we subtract, we multiply, we divide. These are called the basic operations of the basic science. So we will have to know the properties of integers. What are the properties of integers? Under basic operations. That means using these we will know which property holds good for which operation, we will know it. And also we represent the multiplication and division of integers. How will you multiply the integers on the number line? How will you show? Like how we showed the representation, we represented the addition of the integers on the number line. So like this we will do this. Okay? So thank you. Wish you all the best.